Hello and welcome to my presentation here today. First, I'd like to introduce myself. I am Jakob Elmose. I work as a product manager at Johnson Controls. I'm within the responsibilities for compressors, reciprocating compressors, and screw compressors, as well as our chiller solutions. Johnson Controls is a big company with more than 100,000 employees, but myself, I work and represent the Sabro factory in Denmark, where we are a leading OEM supplier of compressors and chillers and standard solutions for OEM suppliers. So today I have a subject that we need to do some actions within refrigeration. We have the fact that 20%, approximately 20% of the world energy consumption is used by refrigeration. So in general, we know that all now due to the crisis we're seeing, that we need to reduce our carbon footprint in general, and we need to protect the environment. At the same time, we have a population growing at 83 million a year, so we have a continuously growth of population, meaning that our problem will just continue to grow unless we do something about it. So keep it into our track and our comfort area. I have here, is it possible for us to reduce the need for cooling? My statement here is no, we don't, because all our world is basically built up against cooling. We need cooling for transportation, for factories, food factories, and keeping our food safe. But is it then possible to reduce the energy we need for cooling? Yes, it is. We have plenty of things to do already now on existing equipment, but also on new installations in the future. The next thing, can we reduce our environmental impact in the generations to come? And here, my statement is the same. Yes, we can change as well on the impact we do for the coming generations. We are at Sabro working with many different refrigerants through the 125 years we have been existed. It has been, the first compressor we made were a CO2 compressor back in the late 1800s. Then we have used a lot of freon types of refrigerants. We have used different natural refrigerants. But if we look over the years, the chemical refrigerants and freon types, they have all disappeared again, replaced by new ones. But the natural refrigerants are still there. So the CO2, the ammonia that has been throughout our history, has been adapted into our portfolio, is the ones that is still being used as a highly effective refrigerant. So we know it works. We have the history and we have the components to go for natural. Not only to promote our products, many other suppliers have the same opportunities here. And we have many natural choices. Here to the right, you can see the options we have that are all natural refrigerants, which has no environmental impact in case of any leaks. And if we look into the history, we had global warming, we have ODP as well, but now we have the new one, the PFAS, and the problem with GFAs and the forever chemicals. So we state we have a choice, and we have to take a decision of what technologies we should use in the future. First, looking into a typical chiller solution. If we look at that chiller solution overall, we know that approximately 80% of the energy going into the chiller system is going to the compression in the chiller system. So the rest is going for evaporator fans, pumps, and so on. And with that in mind, we take a closer look into the compressors, which is our comfort area. We produce, of course, both screws and recips. And we have some rule of thumbs. Oh, sorry. So here it is. So first of all, looking into a existing ammonia system, we have opportunities to improve what we see already, because we have seen from tests that if you have just 1% water in your ammonia, your cooling capacity will be 2% less, and you'll have a 2% higher shaft power. So if you have an existing ammonia plant, then it's very important to look into how is the wealth of the system. Again, look into your what evaporating temperature do you need depending on your process, and try to have as narrow temperature difference from what you need in the process to what you want and specify from your chiller. So basically try to specify a chiller that is fitted for exactly your purpose. Again, 1 Kelvin lower evaporating temperature than needed, that would give you 5 to 8% less cooling capacity and a 3% lower COP. So it's a big impact with the energy cost we have these days. And again, on the condenser side, 1 Kelvin higher condensing temperature, less capacity, again, higher consumption. So it is very, very important. Now I have a slide here that needs a bit more description. We from our business is looking into reciprocating compressors and screw compressors, and I very often get the question, which one is the right solution, or is recips better than screws, and the opposite. And there's basically no answer on that question, because they are both good, and they can be combined to be the optimum system you can do. If we look at if you need to do part load in your plant, it's important to look at the performance of the compressor in part loads. So here I have made 2 examples for a screw and 2 examples for a recip. And here we have the COP, and then we have the load percentage. If I start from top, we have a reciprocating compressor with a VSD on it. So when it's only doing speed regulation on the VSD, when you're going part load operation, the efficiency increases. So that is that basically makes the reciprocating compressor the superior choice for part load regulation. Then if you go, okay, what in terms of efficiency in part load, which one is the next one to come? Then we are looking into a screw compressor with VSD. Then you go down to fixed speed, and on fixed speed you only have the mechanical unloading system. So on a recip you unload the pistons, and on screws you use the capacity slides. So then the 2 worst of the 4. But basically they all start more or less in the same full load performance. So a recip screw is very comparable, but they have a difference in the way they part load. And it matters a lot, because if you compare a screw on VSD versus a recip, if you're going 60% part load, you will be able to achieve 7.5% efficiency gain on that. If you go even down to 30% in part load, you will have a 25% higher efficiency gain on that one. So on your electrical bill, you will definitely see a difference in that. So a small conclusion on this is a system with VSD is of course the best for part load regulation. You can improve it by having screw compressors to take the big capacity, and then use recips to take the fluctuation and the part load conditions. Then you'll have the optimum energy efficient system you can basically do. So the combination of the 2 technologies will be the one where you can get the most optimum efficiency. Then there's a lot of other things to do. Again, this goes into new equipment as well as existing equipment on site. For screws, adding an economizer has always been used. It's a known technology, but you see here the efficiency gain is depending on the evaporating temperature. In the past, what we look into our application is that they have been sold mainly for low temperature applications. But the trend now is changing because it's going to be higher evaporating temperature, because even at 0 degrees, you have a 5% efficiency gain on that, which is actually quite impressive, because if you want to gain, let's say 1% on the motor, that is almost impossible, and also the cost on the motor will be significantly higher. Here we have an economizer for screws that you can gain 5% efficiency gain immediately. So it's really important to think not traditionally, but try to think, how can we improve our applications with the technology we know for decades? Another thing is part load regulation. It goes together with what I just told you about fixed speed and direct driven motors. Then do a part load regulation where it's optimized not for the production and not for load sharing, but basically make the part load for optimum efficiency instead. That will also give you a lot of benefit over a year in production. Seasonal adjustments have a regulation, a VI, with as fine you can get. The best, of course, is you have an infinite regulation of the VI. Then you have the optimum efficiency and no loss in power. Also, when you're designing your system, why always condense at the design condition on the condenser? You can choose to put on a larger motor, enabling you to go down in condensing temperature. And again, you can gain a lot of efficiency doing that. So many things to do that has to be done here. For instance, for the condensing temperature is something you do in the design situation of that. Also mentioned before, optimize your system to the plant. In our catalog, we always pick it according to some standardized temperatures. But if your customers or whoever sits here look into the application you're doing, then see, can we get 1 degree higher evaporating temperature? Is it possible to get slightly lower condensing temperature? Can we change the process so we can achieve a higher evaporating temperature? It will give you cheaper equipment and much more efficient system on that. Yeah, and then of course, when you purchase the equipment, do it according to your load part profile, do it according to your plant, so you get the optimum solution for that. Then also a very simple thing, but not always used. We have a lot of waste heat in the systems. We have the oil cooler. Instead of rejecting it to the ambient air outside, can you recover the heat into your system? Could you preheat a buffer tank? Can you use it directly for some room heating or whatever? Another option is also to have a heat pump on your chilling system. So instead of condensing and throw it out to the birds, to the ambient, you have the option to put on a heat pump. And I'd like to show that case here. This is a process industry. We say that this is big numbers, but 50% of that are going into the cooling purpose. If you take the condensing side, which is a fairly high temperature heat source for a heat pump, you can have a very efficient heat pump for that. And we have the heat pipe system here, where you can basically take your energy from your condensers and you can put it into your process. So doing that, you can have a 70 degrees outlet, more than 1 megawatt, at a COP more than 6. So again, can you use these temperatures into your production? Can it preheat into your boiler? You'll just have saving on your gas. There's so many ways of using the energy. So keep the energy inside your plant as much as possible. And again, none of these is any new things. It's all known things. We know it works. It has been in the market for decades. So it's fairly easy to implement. From the separate factory, we believe in natural refrigerants. We are looking into developing new things. So again, do we believe in chemical refrigerants? If we look, I don't know, 10, 15 years ahead, I think the best value for money for us is to put it into natural refrigerants. If we go around in the exhibition hall, we see I see a trend that suppliers are moving into propane, CO2, ammonia, and so on. So we are on the way. So I'd say new installations, I would recommend going for natural refrigerants because the technology is available immediately. We, from the Danish factory, we use the natural refrigerants. We work for high COPs. We try to optimize for the optimum efficiency over the year, over the seasonal. Robust constructions and so on, but very important also, we have a proven and documented efficiency. So all our heat pumps and all our chillers are going in through a end-of-line test. We always invite our customers to come see it, and here we witness the capacity, we witness the shaft power, the efficiency of the compressor, the COP. So basically what we're selling, we also afterwards prove that this is what the customer is getting. We have a comprehensive portfolio of compressors, reciprocating and screws, and chillers and heat pumps. So I invite you to come to Hall 7, booth 329, and we have a lot of specialists down there that can tell you more about our products, and I'll be there myself. And also I would like to do a little teaser for my colleagues who is also doing some presentations later on today. So if you have time, I recommend you to join and visit them as well. And then we have a few minutes for questions, if there is any. No? Okay. All right. Thank you.